In this video clip, we will prove this identity. Is cosine x over 1 minus sine x, this one, is actually the expression on the right-hand side, which is 1 plus sine x divided by cosine x. It sounds like a magic here is because here we know is subtraction, but here is addition, 1 plus sine x to upstairs if 1 minus sine x is downstairs. Looks quite impossible, but is actually right. You can see here how important the signs are, because even if you changed from negative to positive, then it's going to be denominator comes to be numerator. Only signs are different. Okay, so it sounds quite impossible, but it's actually true. Okay, first of all, we need to note is that cosine x cannot be 0. Cosine x is actually the coordinate in the definition of x right here. You see, we say cosine x, that cannot be 0 means the coordinate of b cannot be 0. That means angle alpha cannot be 90 degrees. Or that means the y-coordinate cannot be 1 if x-coordinate cannot be 0. Similarly, is that here this point, the coordinate of x cannot be 0 means angle cannot be 270 degrees. Okay? Yeah, so that means also y cannot be negative 1. Anyway, is that terminal side cannot be on the y-axis. In this case, we have a y is negative direction on y. Another is terminate cannot be on the positive direction of y. So now let's go back to see the identity proof here. Okay, so this basically tells us that sine can either be 1 or negative 1. Okay, that's what it says here. So basically 1 minus sine x then cannot be 0 since sine x cannot be 1. So this looks like that if right-hand side of cosine x cannot be 0, then the left-hand side will not be 0 for denominator. Now, the common technique to prove this is starting from the left-hand side. Cosine x over 1 minus sine x, and multiplied by 1. Is this 1? Yes, this is 1. Because numerator and denominators are the same. Okay, so then we have a cosine x times 1 plus sine x, and then we keep it, you see, still the same. The thing is that downstairs you have a 1 minus sine x and 1 plus cosine x. You may do by Fourier method. 1 times 1 gives us 1. 1 times sine x is sine x. Negative sine x times 1, so you have a negative sine x. Those two will be cancelled. Okay? Those two will be cancelled. Okay. Then you have a negative sine x times positive sine x squared. So what you get is what? Is 1 minus sine x squared, which is cosine x squared. Okay, because previously what we get is sine alpha squared plus cosine alpha squared was 1, Okay, then you subtract sine alpha squared on both sides. You get those two cancelled. Okay, so you have a cosine alpha squared left. In this case, we have cosine x squared left. And here is 1 minus sine alpha squared. And here is 1 minus sine x squared. Okay, so then denominator is 1 minus sine x squared, which is cosine x squared. Cosine x squared downstairs with cosine x squared, they may cancel 1. So downstairs you have a cosine x. Upstairs there will be no more cosine x. And you just copy 1 plus sine x right here. So this expression will be the expression on the right. That's the proof. Okay, I'll see you next time.